Hey guys, my name is Trevor Sullivan, and I am a solutions architect with StratusGrid. We are a consulting partner with AWS. And in this video, what I wanted to do is cover how you can use the new generally available Rust SDK for AWS in order to interact with a managed service called the Amazon Rekognition Service. Now, the Amazon Rekognition Service is a machine learning based service that allows you to detect different things with images and videos. Now, this is a really cool service because it's fully managed, right? So if we head out to the marketing page for Rekognition here, you can see that it allows you to perform recognition on things like faces. So you can detect if a person's face is actually live or if it's just a static picture of a person. So that way you can detect if you're actually dealing with a real person or just an image of that individual. You can also do things like content moderation to detect explicit materials that maybe you don't want to include in your image library. You can even do things like custom label detection as well. So if there's a logo that you want to be able to detect, then you can go ahead and import your custom labels and teach the service how to recognize those custom labels as well. You can also do optical character recognition or text detection, as they call it right here, to extract text out of an image, which is really cool. Maybe you've got video of road signs or something like that, and you want to be able to extract the names of roads and things like that. You can do that. But we're actually going to be taking a look at something known as label detection, sometimes also known as image classification. What this task in the computer vision ecosystem essentially allows you to do is to detect certain descriptors of a particular image file. So as we take an image like this one right here that they have as a sample, you can see that there's a bicyclist. They're in an outdoor environment. There's a mountain bike. There's mountain peaks or crests off in the distance. There's a lot of rock in the picture as well. So all these different labels kind of describe what's in the image. It's not necessarily pinpointing those specific objects in the image, but it's just generally describing what it's seeing. So if we take our own custom photo and upload it into that service, it'll give us the results on that custom image in very close to real time. It's actually a pretty fast service. So you're going to want to have an AWS account if you'd like to follow along. Also, I'm going to be using a service known as GitHub Codespaces in order to actually write and compile and run my Rust application. So if you want to follow along, you might also want to sign up for GitHub and use the Codespaces service to actually write your code. But you can also just install the Rust tool chain locally on your development system and go that route as well. So it's really up to you. But just so you know, those are a couple of the services that we're going to be using. So make sure you sign up for AWS if you don't already have an account, and then you'll be able to follow along. Now, I did want to mention that just recently in November of 2023, it's currently the end of December 2023 right now, so just about a month ago during the reInvent timeframe, AWS actually announced the general availability of the Rust SDK for AWS, so it is generally available and supported for production use. Now, there is still some core functionality that's missing. I think the single sign-on capability for the Rust SDK is still missing. I know that's something that a lot of people, including myself, are waiting for in this SDK, but you can use things like static credentials for the time being, and there's other ways to authenticate to AWS aside from using single sign-on, or IAM Identity Center as they've since rebranded it. So just be aware that this is generally available, and there have actually been some SDK changes. So in some of my previous videos that I've created, some of the API calls in the Rust SDK might just look a little bit different, or when you install the create dependencies, those might look a little bit different as well. But it is generally available now, and so it's generally going to be stable going forward, hopefully. So what we're going to be doing is going into our AWS account right over here. And if we navigate to the Rekognition service here, we've got all these different features. We've got, facial analysis that we talked about, text extraction. We're going to be taking a look at label detection right here. And if I just upload my own personal image right here, this is actually an image that I generated with Stable Diffusion right around the Christmas time this year. You can see that we get these labels over here that kind of describe the image, right? And it's not necessarily pinpointing everything in the image, but it's giving us kind of a general description of what the Rekognition service sees. So it can see that there is a couch somewhere in the image. It doesn't really matter where. It can see that there's furniture, it can see there's side tables. It sees that there's architecture. We're inside of a building, so it's indoors. We can also see that there's a living room environment just based on the furniture and the environment that it sees. If we click on show more, you can see that there's an animal detected. And so we have these generic tags like animal, but we also have more specific tags or descriptors or labels, whatever you want to call them, like canine, dog, mammal, pet. It can also see that there are Christmas decorations, Christmas tree, festival, celebration, that kind of thing. So it's really able to just extract a lot of interesting metadata about this image that we fed into the service. Something that's kind of interesting here, though, is that there are some limitations on the images that you can upload. For example, only JPEG or PNG is supported, and you are not able to exceed 5 megabytes in size for that image. You can also point it to a URL right here, or if you're using the APIs, you can actually import an image file from the S3 object storage service if you would like to. But the easiest way to use this service is really just to feed an image directly in as a binary blob. So that's what we're going to be doing using the Rust SDK. So what we're going to do is go over to our GitHub organization right here. So github.com/stratusgrid. Of course, you can have your own user account on GitHub or an organization. And we're going to just create a brand new empty repository, right? So we're just going to call this AWS-rec for now. And we're going to make this a public repository. And actually, we're going to do private for now. And then I'll just choose the Apache license here, and we'll hit create repository. Now, once we have this empty Git repository here, I could clone it locally, but I'm actually just going to go ahead and use the GitHub Codespaces service to create a brand new cloud-based workspace rather than having to actually clone my repository locally and everything. So we're actually going to be running the Rust toolchain on this remote Codespace environment. And I'm just going to disable Dark Reader here so that that's not fighting with the theme of VS Code in the browser here. But once this code space is up and running, we'll basically just want to make sure that we have the Rust toolchain installed so that we can compile Rust applications. Then we'll initialize a new application, of course, using the Cargo CLI tool, as we typically do. And then we'll go ahead and actually start installing our dependencies and writing some code, setting up our credentials, and all that fun stuff. All right, so for starters here, once our code space is available, you can see that we've just got our repository cloned automatically here, so we don't have to worry about setting up SSH keys, and we just have the license file here. But we want to actually use the terminal here to make sure that we actually have the Rust compiler and the Cargo CLI and all the other tools that we're going to need installed. And so if you head over to rustup.rs, this is the website where you can just copy this little snippet right here, clone that, and then run it inside of your development environment, and that will install all of the Rust toolchain tools. All right, so once our terminal is loaded, we'll go ahead and just paste in the command to install the Rust toolchain down here, and we'll just hit enter to use the default installation of the latest stable version. Once the Rust toolchain is installed, we'll be able to use the Cargo CLI to initialize a new project. While the Rust toolchain is installing, though, we can go ahead and generate some credentials as well. So if we head back over to the AWS console here and just search for IAM, head over to the IAM service. We'll create a user right now and call this AWS rec, and we'll go ahead and hit next. And we will attach policies here, and we're going to search for a built-in policy called Amazon Rekognition Full Access right here. And then we'll go ahead and just create that user. So once we've got that user created, we'll go over to the security credentials here, and we are going to create a new access key. And these are the credentials that are going to be used from our Rust application to authenticate to AWS. So let's go ahead and just hit create access key right here, and then we can go ahead and copy these two values and bring them over into our workspace here. Now we're going to want to make sure that we create the home.aws directory here, and then we're going to go ahead and open up the home.aws/credentials file right here. And this is going to be a new file that we create in our home directory. And what we want to do is create a profile here called default. Let me actually go ahead and just open this up in VS Code instead. So let's do code.aws credentials. And that should open it up in our editor right here. And this will just be a little bit easier to work with. So what we're going to do is create a profile called default, and then we'll say AWS access key ID, and then paste in that access key ID. Then we'll do AWS secret access key, and we'll set that to the secret value that we copy from the console right over here. You can also just click on show to view that value, and then we'll paste that in. And we're also going to set region equal to US West 2 for now. So let's go ahead and just save this credentials file to our local file system here. And the AWS SDK for Rust will automatically look for that file according to the documentation. So if you look at the documentation for the Rust SDK here, and you take a look at credentials and region, you can see exactly this home directory right here that's going to be searched, and then the structure of this file right here, as well as how to set a region. So feel free to refer back to the SDK documentation if you have any questions about how to set this up. All right, so now what we need to do is to go ahead and install the SDK itself. So since we've got the Rust toolchain installed, which we'll validate by doing a rust c -- version, looks like it's not available quite yet, so let's exit out and reestablish our terminal here. So now if we do rust c -- version, we should see that we've got the Rust toolchain version 1.75. And if we do cargo -- version, that's our package manager. As you can see, that's available as well. So now we'll just do a cargo init dot to establish a new project in our current directory. And our package name is just going to be based on the name of the directory here, which is the GitHub repository name that we called AWS-rec, but you can always change the name of this package to something else if you would like to, just to keep it unique in the crates.io registry. All right, so now that we've got our project initialized here, let's actually take a look at the crates that we need for our Rust project. So let's go ahead and go to crates.io. This is the repository where we can install different crates from using the Cargo CLI tool. So first we'll do a search for AWS config right here. This is what allows us to load our credentials. It's really simple to do that with this function called load from env right here. That'll just automatically search for your credentials file in your home directory. But then if we take a look at AWS-SDK as a prefix, let's do a search for -rec here, you can actually see that there is this crate specifically for the Rekognition service. So there's also crates for other services like S3 or maybe DynamoDB, for example. There's a separate crate for that. So everything is segmented out by service in AWS. And in this case, we're going to install this particular crate in order to interact with the Rekognition service from a Rust application. Now, something that has, I believe, changed in the generally available version is that there is a feature, so a crate feature that is exposed called behavior version latest. And basically what the Rust SDK team has done, it's a little bit weird at first, but once you've done it a few times, it kind of makes sense. But in order to account for any API version changes, any kind of breaking changes between different API versions, they've given this behavior version. And if you just use latest, then you're always going to get the latest version. And most oftentimes it'll be okay to just rely on that. But in some cases, you might want to lock to a specific behavior version. So just be aware of that breaking change that occurred, I believe, again, when they went GA with the SDK. So what we're going to do is come back to our project, and let's go to our GitHub code space here. And we're going to say cargo add, and then we're going to say AWS-config, and we'll say features equals behavior version -latest. And so that should install the core AWS config crate. And then we also want to install the AWS-SDK-Rekognition with a K, that crate as well. And we'll also use that same behavior version latest. All right, the other thing that we're going to need is, of course, the Tokio runtime. So we'll say cargo add Tokio -- features equals full. And Tokio is essentially the asynchronous runtime that we use in most Rust applications in order to do any kind of async operations. So when we're dealing with AWS SDK applications, we do need to make sure that we use an async runtime and set our main function as async here as well. So let's go ahead and specify the Tokyo main attribute right here and specify the async keyword on our main function. And so now anything that we put inside of our main function here can be async in Rust. All right, so this is the base setup for our application. We've set up our AWS credentials file, which isn't part of this project folder. It's part of our home directory. And we've also installed some dependencies here. As you can see in our cargo.toml file, we've installed the Rust tool chain. And now we are ready to go ahead and actually write some code in order to interact with the Rekognition service. So the first thing that we typically do when we build a new application using the Rust SDK here is to not just set up the async main function, but we also need to go ahead and create a credentials object. And we actually saw that over in the documentation here. So in the crates.io documentation for the Rekognition SDK, you can see that they are using the AWS config crate with the load from env function, awaiting that, and then assigning that to this config variable. So we're going to go ahead and reach into this AWS config crate and load our credentials from the home credentials file. So back in our project here, we're actually going to go over to extensions right here and search for Rust Analyzer. And we'll go ahead and get the Rust Analyzer extension installed, which should give us some auto completion capabilities that are not built in by default in the VS Code environment that GitHub Codespaces provides. So we'll go ahead and install the Rust Analyzer extension and then just come back to our project. And so it'll take a moment for it to actually inspect all of our crates, but eventually we should be able to start typing here and it'll do some auto completion for us. To kick it into gear here, I'm actually just going to go ahead and do Control-Shift-P, and we'll just say reload window right here, and hopefully that will invoke the Rust Analyzer extension, and you should see it pop up down in the bottom status bar of the editor interface here once it is active. Now, due to a bug that I'm having with Chrome and Codespaces, I'm going to go ahead and open up my Codespace remotely in VS Code from my local workstation here as well. So we're still executing on the GitHub Codespace instance. I'm just using my local VS Code to remotely connect to it. So now what we want to do is start writing some code to go ahead and load our credentials. So what we're going to do is call the AWS config crate, and then we're going to call the load from env function here. And what that's going to do is return a configuration, but this is async, so we also need to await that. And then we'll go ahead and assign the result to something like SDK config. And so now this SDK config variable here is going to contain the SDK configuration with our credentials, as well as the AWS region that we want to execute against, and we can pass that into our Rekognition client. In order to create the Rekognition client, we need to import the crate for Rekognition. So let's go ahead and go up here to the top of our file, and we'll say use AWS SDK Rekognition as rec. So what we're doing here is basically assigning an alias to this longer crate name so I can reference it inside of my code as just rec for short. So then we'll go down here and say rec, and then go into the client module here and create a new client object. And we can use the new method to accomplish that and simply pass in a reference to our SDK config. So let's do ampersand SDK config here, and that will go ahead and construct our client. And then, of course, we need to capture that in a variable like rec client. So now this rec client variable is going to allow us to call different functions against the Rekognition service. Let's head over to the documentation and take a look at how to call the rec client dot. And then we're going to do detect labels right here. And we're going to take a look at the different input parameters that we can pass into this function call in AWS Rekognition. So we'll do detect labels here, and let's head over to our browser here, go to the Rekognition documentation over at docs.rs, and then we're going to go take a look at the detect labels function here. And this is actually the official REST API documentation. It's not the actual Rust documentation here. But if we take a look at the request parameters right down here, you'll see that we have to pass in an image as an object into this API call in order for it to know which image we want to perform label detection against. The way that we specify the image in Rust is a little bit bizarre, though, especially if you're new to Rust or even new to the AWS SDK in general right here. So let's go up to the search bar here and look for the detect labels function here. And then we're going to go ahead and take a look at the parameters for it. So that'll be under the detect labels input structure here. So as you can see, the inputs to this particular function call are going to take an image, which is actually an option type that contains a image. And the image itself can either be a reference to an S3 object, or it can have this bytes field here, which is actually an option wrapping a blob type here. Now, the blob type is actually a primitive struct that's defined in the Rekognition crate itself, so we need to figure out how to actually construct one of these blobs. So first we need to construct the blob, then we can create one of these image structures, and then we can pass that image into our input for the detect labels function. So what we're going to do is switch back over to our code right here, and let's just comment out line number 6 for right now. And what we're going to do is start by constructing one of these blobs. So if we just type blob here, you can see that the Rust analyzer automatically detects that there's a blob type under rec primitives blob. So if we just click on that, it'll automatically use that type so that we can reference it in our code without the rec primitives module prefix there. So what we're going to do is construct one of these blobs by using the new function here. Now we have to pass in some data as input to construct one of these new blobs. And the input that we're going to pass in is actually going to be the vec of unsigned 8-bit integers, which is actually the raw file itself that we're going to input. So we don't have a test image in our project right now, but let's go ahead and just create a placeholder image. Let's call it maybe something like testimage.jpg. And so what we want to do is basically grab this testimage.jpg that does not yet exist and load it into a variable. So to do that, we're going to reach into the standard file system module here, and then we're going to use the read function here and specify the path to the image file that we want to load, and that's going to return either a vec or error, depending on if we get a successful result or an error due to maybe missing permissions or a missing file path. So what we're going to do is just go ahead and unwrap that so that we can actually get the underlying vec, and then we'll say let my input equal the results. So now this my input variable actually contains a vec of U8, and we can simply pass that directly into the blob constructor right here. So what we're going to do is assign the result of this blob to a variable called input blob. And now we can take this blob and construct an image struct. So on the next line right here, we'll just do a search for the image type. And as you can see under the rec types module rather, there is actually an image type. So we're going to go ahead and hit enter to use that. And as you can see, Rust Analyzer imports that again for us automatically. And so now what we're going to do is create a builder, and we're going to set the bytes field here to the input blob. Again, if you take a look at the documentation right over here for the image type, it has a field called bytes, and that is going to be the blob wrapped by an option. So once we go ahead and do that, we'll say .build here, and that will build the image. So we'll say input image equals the result of that. And so now we finally have this image object that we can pass into the detect labels call. So now down on line number 11 right here, we can go ahead and uncomment this. And we are going to call detect labels here, but remember that because the AWS SDK is asynchronous, this does not actually get triggered until we call the .send function and then await the future from that send function. So what we can do in the meantime here is set certain input parameters, like the image input parameter. Again, going back to the documentation of the input structure here, you can see that there is an image field that points to the image that we want to upload into the service. So we're just going to specify the input image variable that contains the image struct right here, and that will satisfy that input. Since that's the only input argument that we're going to need, or request parameter, we'll go ahead and now just do a send dot await, and then we'll capture the result into a variable like rec result equals the result of this operation. Now, as you can see, we get another result type here. So this is a common pattern you'll see in Rust applications where the result either contains the final results or an error, just like we saw before with this type up here, where we were reading a file or potentially getting an error. So we're going to have to unwrap the result called detect labels output, which is this type right over here. Under detect labels, we have detect labels output. And so what we're going to have is this field called labels that contains an option of type vec label. So we'll be able to iterate over this vec once we unwrap it and retrieve a list of all the label names as well as the confidence score of each of those labels. So what we'll do is go down here and say if rec result dot is error. So what we want to do is basically check if an error occurs from this result right here. And then we'll go ahead and just say print line, some error occurred during the Rekognition API call. However, after that, we'll go ahead and write some code that should happen if there isn't not any error. So we'll just do a return statement here as well so that the function returns if there's an error. And so now what we're going to do down here is do rec result dot unwrap, and that is going to give us the vec of label. Actually, that's going to give us the detect labels output, but then we can go ahead and grab the labels field here, and then we can unwrap that. And so now once we unwrap the labels field, that's going to contain the vec of label that we can iterate over with a for loop. So what we'll do is say for current label in the results here. What we're going to do is go ahead and just print out each label. So we have a label reference for each iteration of this for loop, and we're just going to grab the name and the confidence score of each of these labels. So we'll say print line, and then we'll do a name colon with a placeholder. Then we'll do a confidence colon, and then another placeholder. And then we'll go ahead and do current label dot name. And then we have to unwrap the name, because if we take a look at the documentation, the name is actually wrapped in an option type here. So we need to unwrap the option to get the underlying string. And then same thing with confidence. That's a floating point 32-bit value that we need to unwrap from the option. So we'll do current label dot confidence dot unwrap to get the confidence score. So basically what we're going to do here is run the object detection. Then if an error occurs, we'll just print that out and exit the program. But if there is a success, we'll just print out every single label and the confidence level, which is a percentage of confidence, 0 to 100, that the service thinks it has for each of those labels. The only other thing we need to do at this point is to make sure that we have this file right here called testimage.jpg inside of our project directory here so that we can actually reference it from our program. I should be able to just drag and drop this image here that we tested before in the web interface, and then I'll go ahead and just rename it to test_image so that it matches the file name that we hard-coded into our program here. You could also take this input file name as a argument using the OSArgs if you wanted to, but in this case, I'm just going to hard-code it for simplicity. All right, so now that we've got that image up there, we've got our credentials set up, and we've got all of our code written here, let's go down to our terminal here, and we're going to do a cargo build to make sure that our program compiles successfully, and then once that's done, we can go ahead and attempt to run it. All right, so compilation of our program is complete, and now we can go ahead and do a cargo run operation here, and that should just run our binary. And as you can see, sure enough, we get all of these different labels as well as a confidence score. So it's very confident, 97% that there's an animal. It's 97% confident that there's a dog. It's 77% about rounded up that it is a Christmas theme and things of that nature. So this is a really cool way to use the Rust SDK for AWS in order to run label detection against different image files that you're gathering from different locations. Now that you understand how to use the Rekognition SDK for Rust applications, feel free to experiment with it yourself, build your own applications, and you can expand on this concept using other techniques. For example, maybe you've got a directory that has hundreds or thousands of different image files that you need to do detection on. So feel free to write some additional code that iterates over that list of files instead of just loading a single file. Something else that you could do to expand on this application would be to take these labels and rather than just printing out the information to your terminal like we did right down here, you could actually store that data long term into a database somewhere. Maybe you're building up a photo library that you want to be searchable. There's a whole bunch of different things that you could do once you understand this fundamental concept of using the Rekognition service. So thanks again for watching. Again, my name is Trevor Sullivan, a solutions architect with StratusGrid. If you're interested in engaging with StratusGrid, just head out to our website at stratusgrid.com, hit the Let's Talk button up here, and you can fill out this little form over here, and one of us will be in touch with you. Thanks for watching, and take care.